K-Water is a public company specialized in water resources management. We provide various international water education programs for the developing countries to solve water-related issues all around the world. Today's topic is global trends of climate change and how to overcome the problems in water resource management in Korea. In the Ice Age, the average global temperature was about 8 degrees Celsius, and in the 1900s it was about 15 degrees Celsius, and in the 2000s about 16 degrees Celsius. After 20,000 years from the last Ice Age, the temperature increased by around 7 degrees Celsius, shows an average annual increase of 0.00035 degrees Celsius. The increase of 1 degree Celsius during the last 100 years is 10 times faster than before. So, what is the expected average global temperature in 2100? The average global temperature continues to rise. It might be fair to say that the average temperature of the Earth in the future depends on how mankind acts. The global temperature is 1.1 degrees higher than before industrialization. Precipitation is also rising, and the world is now experiencing extreme weather events. In Korea, water-related disasters, such as floods and droughts, have soared, and their scale are also increasing. We believe that this phenomenon occurs as the water circulation cycle becomes faster, which is caused by global warming. Then, why is climate change happening? The Kyoto Protocol pointed out greenhouse gas emissions affecting global warming as the main factor. An index showing the level of effects of each gas is called GWP, or Global Warming Potential. Assuming that carbon dioxide, which accounts for 90% of the major greenhouse gases, has a global warming effect of 1, the graph indicates how much other gases affect global warming during the same period. Moreover, greenhouse gases generated from air conditioning refrigerant and electricity-related processes have a significant impact, even if their influences are smaller than those of carbon dioxide or methane produced from landfill sites. According to the report by IPCC, Intergovernmental Panel on Climate Change, an international organization on climate change, in 2018, the average temperature of the Earth is expected to sharply increase from 1.9 to 5.3 degrees Celsius in the second half of the 21st century. And this will be 1.5 degrees higher than the recommendations of the Paris Agreement, even while the mitigation and adaptation policies are in effect. It is also predicted that precipitation will rise to around 5 to 10 millimeters worldwide in the second half of the 21st century. In this context, the Paris Agreement was adopted and put into effect as a response to climate change. The agreement aims to keep the global average temperature rise below 2 degrees Celsius, preferably to 1.5 degrees Celsius, compared to pre-industrial levels. Participating countries are required to voluntarily set and submit national reduction targets every 5 years. Moreover, it must present an improved target than the previous reduction target. The new climate regime and the first global stock-taking were also adopted. Within the global stock-taking, countermeasures against climate change have been actively prepared and taken based on climate change mitigation, adaptation, implementation, and support. Thus, the IPCC's special report also includes the goals such as strengthening global response, sustainable development, and efforts to fight poverty. The most important thing is for the human to recognize the severity of climate change. So politicians and media around the world have called for changing the word climate change to the word climate crisis or climate emergency. So, how is K-Water coping with climate change? In fact, in order to tackle water issues related to climate change, a proper mix of mitigation and adaptation measures is required. However, it is practical to handle water resources based on management and reduction. Of course, we are also establishing measures to reduce greenhouse gas emissions by utilizing renewable energy sources in water supply facilities and flood protection facilities. Therefore, this chapter will focus on non-structural adaptation measures through the operation of water resources facilities. South Korea is not a big country, with a land of about 100,000 square kilometers. Since mountainous areas account for more than 2/3 of the entire land, there are many dams for flood control and drought management. K-Water is an institution for comprehensive management of multi-purpose dams and water supply dams in Korea. The management of multi-purpose dams that flexibly control water resources by adapting to climate change is becoming more crucial. In particular, 21 multi-purpose dams and 14 water dams run by K-Water are responsible for about 70% of Korea's water control. In response to climate change, the basic principles for water resource facility management are to use multi-purpose dams to defend against floods in case of heavy rain and typhoon, and to smoothly supply water to protect against drought during the dry season, rest of the period. Let's look at the basic principles and rules of water resource facility management. First, water resource facility management is governed by the River Act, the highest law in the country, and Act on Construction of Dams and Assistance, etc., to their environments are applied. Also, there are the Ministry of Environment's instructions for the joint operation of dams and weirs, and K-Water's dam management regulations. The basic principles of dam management are based on the Dam Act and the Dam Management Regulations, which include items such as improvement of public interest with dam reservoir, elimination or mitigation of flood damage, and efficient operation as intended. The Dam Operation Plan complies with the regulations for dam management, and K-Water establishes an annual and monthly operation plan. The annual plan shall be reported to the Ministry of Environment in October, when the flood season is over every year, and the monthly plan shall be reported before the start of each month. The main contents of the plan include the current and end-of-month operation levels, the previous month's supply, and the next month's planned water supply. The Joint Operation Plan for Dams and Weirs was designed to establish separate operation plans for linking dams, weirs, and reservoirs in 2012. The plans are annually, quarterly, and monthly built, but also established under the necessity of situations. The Dam Operation Plan is the same as the Operation Plan according to the Dam Management Regulations. The 16 weirs installed in the rivers are separately operated by normal, flood, drought periods. Normally, it is run flexibly within the normal water supply to the upper limit level. In the event of flooding, effective flood control is possible as movable weirs operate. During droughts, the water is supplied from secured water storage at the lower limit water level to the normal water level. In order to draw an actual plan, K-Water first analyzes current water storage and inflow. Estimated inflow and water storage need to be adjusted. Only after the operation adequacy is reviewed and confirmed, the supply plan can be decided and submitted to the Council. The operation plan for the dams and weirs by water system submitted to the Council will be finally implemented as an operation plan decided by the Flood Control Office of the Ministry of Environment after consultation with the Dam Weir Joint Operation Council. It consists of interested parties such as K-Water, Korea Rural Community Corporation, and the public officials. Next, let's look at the water use priorities by purpose under Article 7 of the Dam Management Regulations. During the flood season from June 21st to September 20th, flood control should be prioritized. In the event of abnormal drought, domestic water is supplied first, followed by industrial water, agricultural water, river maintenance water, environmental water, and power plant water. In accordance with the dam water supply adjustment criteria, the water is reduced as following 4 stages. At the attention stage, domestic and industrial water is reduced as not agreed. At the caution stage, 100% of river maintenance water and reserve quantity by water. At the alert level, the reduction at the caution stage and agricultural water. At the serious stage, the sum of the reduction at the alert stage and residential and industrial water is reduced. It is essential to consult with the relevant agencies at the caution, alert, and serious stages. Then, how is the dam operated during flood season? At first, the conditions of the dam gate is monitored in real time, such as water level, inflow, and precipitation. Second, precipitation is predicted by basin. At this time, the KMA, Korea Meteorological Administration, and K-Water's rainfall forecasting systems are used. Next, the flood analysis by dam and water system is done to determine the outflow and timing of release. Then an alert is broadcast and downstream patrol is carried out. As for alert broadcasting, it is essential to notify related agencies and residents 3 hours before the release. Lastly, a water gate is operated. K-Water operates the water gate first and reports the results to the Ministry of Environment and the Flood Control Center. There's a reason for making a lot of effort for water facilities operation and weather forecasting through these many steps. This is because the improvement of the accuracy of precipitation prediction leads to the accurate prediction of flow in the basin through quantitative numerical prediction. In addition, a combination with the field survey data of precipitation radar improves the performance of predictions for 10 minutes to 1 day, which improves the short-term prediction performance essential for flood control in cities and basins. And in the short and long term, by linking dams in the most appropriate way through the analysis of interrelationship between them, water supply and flood prevention plans can be realized. Currently, various methods have been studied to improve the operation technology of reservoirs with precipitation and discharge predictions. To this end, we have developed a rainfall runoff model that analyzes the basin with units of around 100 square kilometers and an analysis model that subdivides the basin by increasing the resolution by 10 times or more. And they are currently under test around the upstream basin of the dam. The operation of the subdivided rainfall runoff model requires the proper use of the suitable rainfall radar and advanced rainfall forecasts. Ultimately, these technological advances will serve as a countermeasure to changes in water resources caused by climate change. So far, we've learned about global trends of climate change and how to tackle the difficulties in managing water resources. Thank you.